Hi again, everybody. This is Joseph, and we're going to discuss again how to read automotive schematics. Again, dealing with BMW, because their schematics are a little sophisticated and complicated at times. As I specified the other day, when you start about analyzing or trying to understand how to read the diagram, you pay attention to significant or key components. Sometimes you have to look around the schematic to analyze it, to understand what abbreviations stand for. So therefore, as we said before, let's say we're concentrating on, we know this is the symbol for a relay. We know this is the symbol of a transistor. And we know this is a symbol for a fuel pump and the fuse. Electrically, an electric fuel pump. Now, first, before troubleshooting, we have to understand how it works in the first place, obviously. So what you're paying attention to, again, is key components, main components. Now, in this type of diagrams, we know it goes to B+, and it goes to the battery. That part is not shown here. That's the difficult part. We have to understand that things go to the battery. We need a B+. So where you see over here B and where you see over here E in a triangle form, that means there's another part of a diagram going to B. So if you need to see where this is connected to, you look over the schematic and the other pages for B. If you want to know where this is coming from, E, then you look for E and the other parts of the schematic. There could be A, B, C, D, E. Now, before we get to troubleshooting, again, stress the point. BMWs, we know, they like to use transistor components. If you saw my other video, I stressed the point that there was a symbol of a transistor, telling me that probably transistors are in the module, and we said that transistor could be used as an amplifier or it can be used as a switch. And I made the point that in that module that we were dealing with, that transistor probably was used as a switch. What brought me to that theory? Like, let's say I'm trying to understand how to read a diagram. Well, first of all, how do I know there's a transistor in here? Well, if you look at another one, if you look at other modules, remember there was a transistor symbol right here, and this is a module. That's how I figured out transistors must be in here, and they must be used as switches, on and off switches. A transistor can be used as an amplifier, as we spoke about. But there is no amplification needed here, because there is no input signal and output signal. No sine wave or anything to have gain or amplification. Therefore, I came to the theory that whenever you see this, for BMW, they're big on this. As you see, mass airflow, air mass meter, they like to use transistors. That's why I came to the conclusion. Number two, if you look at the diagram, a transistor has an input, has an output. There is a capacitor across this. This is a symbol for a capacitor across this. It will hold a charge. A capacitor holds a charge once it is charged. Once it gets rid of the charge, it's called discharging. That means current will flow to the component across it to discharge. So electrons will flow from one side of the capacitor through the transistor to the other side. In order for something to happen, in order for this transistor to be activated, the front of it has to be turned on, as we see. So in other words, this is the input, where you see over here, has to be triggered on, and then this will be turned on. That's how transistor works. That's being applied, the application of it is a switch. It's just for being on and off. Now we're looking at the schematic, we're trying to figure it out. Boy, how does an electric fuel pump work? I put over here notations of numbers. The sequence of events that has to happen. Number 1, I put over here for the transistor module. It's called the control unit. And why is it called the control unit? Well, off the top of your head, you say, something must be controlling this, and this must be controlling something else. Exactly. The computer is controlling this transistor to be used as an on and off switch. How do I know that? I look at the symbol, how it's connected. The computer, called the PCM or ECM, either abbreviation, either function, when you turn on the ignition switch, it knows, hey, I have to turn on the fuel pump. What else am I doing when I'm turning this on? Guess what? We spoke about main components. Well, relay. Which part of this has to be turned on first? This is a control circuit. This is the controlled circuit. First, we need current to flow through this coil. The dotted line represents that the contacts will be moved for the armature. This will be pulled in, as I have signified by the yellow line here. In order for this to happen, we need current to flow. In order for current to flow, we need this to be ground. This transistor to be activated, to be triggered on. What triggers that on? The computer. You see this dotted line? That means there's another part of this module, this control unit. So pin 1 is over here. 31 is ground. Pin 31 is ground. Now, we said we need a complete path for current to flow. If this is not activated, I do not have, it's like open. Current cannot flow. Once this is activated, current can flow. Current can flow. Current can flow here. Activating this part of the circuit. This is number 3. We need this to happen first. This to happen second. Without this, this cannot go. When this happens, contacts are being pulled in this way. Now current can flow through here, through here, through here, through the fuel pump, through the ground. This is the motor. That's in the fuel tank. So therefore, reading a schematic, as we said, you usually start at the top. But since I know the symbol of a relay, I know something has to turn this part on first. And looking at the diagram, at the symbols around it, I say, okay, this has to give me a ground. This is like a short circuit when it works, knowing how a transistor works. So first you have to know how the symbols work. Then you can figure out how to read the diagram. Very important. As you see over here, there's a fuse, and the fuse rating is 15 amps. The fuse sometimes could be over here. The fuse could be over here. Before a motor, we have the fuse usually. Okay, very confusing, but that's how an electric fuel pump works. Remember, I could put a ground over here. Instead of a transistor, current flows here. That allows this part of the circuit to flow. If I want to troubleshoot, where am I going to put? Everything is 12 volts. 12 volts here. This is 12 volts. How do I know this is 12 volts? This is connected to the battery, which is 12 volts. It's going to be 12 volts if it's not operating. When it's operating, this is going to be 0 volts. Right? So when this is grounded, the transistor is like a short circuit. The ground, it'll measure maybe 0.2 volts, something like that. We can consider it ground potential. And it'll be at 0 volts. If it's not, it'll be 12 volts. Again, when this is operating, this will be grounded. Therefore, this will be now connected to the battery at 12 volts. So again, for troubleshooting, I want to know where to put my probe, my voltmeter probe. I always say, go over here. If I have 12 volts over here, guess what? That means this is working. That means this gave me a ground. Because current is flowing here. Automatic. I don't have to go 12 volts here. I don't have to go 12 volts here. Once I go to this point, pin 2 of this, then I know then I know that 12 volts over here tells me, hey, this is working. I had a similar question. The reason I point out this, what I'm saying, is because I had a question on an email, someone about a previous video that I made, and he was a little confused and wanted to understand why I would go, when troubleshooting, why I would go to this point. And the diagram that we were talking about was this one, also BMW fuel pump. And he was a little confused why I said to put the meter over here at 12 volts. If you look at the video, I said, number one, for this has to happen, this has to happen, then this happens. But the most important thing is I need a ground. That's why I brought out the other diagram to show you. That control unit, if you remember, was a transistor. Here there is no transistor symbol here. However, I know something has to give this a ground, so might as well give this a ground, a symbol of a switch, symbol of a switch. If I go over here and I measure 12 volts, guess what? That means this is working. Current is flowing through here. Most important, this computer gave this a ground. So I know this is working. It gave it a ground. And I know this is working because this also gave it a ground, and the current is flowing through here. If current is flowing through here, that means the contacts are being pulled in, then I have 12 volts. So what I'm saying is, the fact that you're measuring it in one shot, I don't have to measure here, here, here. I measure over here 12 volts. That tells me this is working. Current is flowing through here, creating a magnetic field, pulling this in. And why is this working? Because this gives me a ground. So I know this is working. If this is working, that means this is working. And why is this working? Because this is working. And why is this working? Because this is working, giving it a ground. So in one shot, I know this is working. All this PCM is working. This ECM actually is a computer is working, giving it two grounds, a ground here and a ground here. Thus, pulling this in, activating this one, activating this one. And that's why I go here for 12 volts. And that's why, in one shot, instead of wasting, going all over 12 volts, 12 volts, 12 volts, I go right here. I know this is working, 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 this is working. You will not see this anywhere else on YouTube, a troubleshooting like this. But you have to understand how, first, like I said, how it works. Let's go over a similar one. Okay, this is a little similar. Like I said, the starting point. Where is the starting point? I'm looking around, and it doesn't matter. I have no relays here, correct? I have no modules over here. What I have over here is, again, BMW, the lights going on. Well, main component, the switch. A right signal or left signal. The arrows indicate right and left this way. The switch has multiple points that it can make contact with. And therefore, the connections go to the points. So therefore, this is 3 points, a switch. As you can see, I put this one, this one. We know we have bulbs, right turn signal and left turn signal. In this way, this is right. When you go this way, when you turn on the switch. When you go the other way, you're turning on the left bulbs. We have rear, we have front, park. Therefore, this, we see no B+. You're not going to always see a B+ or a battery symbol when it comes to automotive. You will see in other schematics, but not in this. The fact that you see this little wing over here, I don't know if you can see it, means there's a connection to somewhere else. See this and this? That means there's a connection to somewhere else. Somewhere on another page is another part of that schematic. Now, going over here, current flows. Now, we come to let's say we put the switch for the right signal, turn signal. We want to try to figure out how to read the schematic. We said a couple of things. First, which position do we want to be in? We want to be in the right turn signal. It goes this way. Now, current flows through here. Remember, current is flowing through here, here, here. It does not flow here because there's no connection. It's open circuit over here. So current can either flow here, there is a connection, or current can flow through here. Now, I colored this in to show you we have multiple paths. When you come to this node, we have multiple paths that we can take. So therefore, the current will flow in these branches. These are called branches, right? Like parallel circuit. Therefore, current will flow here, not here, because there's no connection here. Flow over there. This current will flow here. Now this has two bulbs in it, but one is being used. As you can see, a double filament. One here, one here. So if you want to go, we go to this 1, 2, 3, 3 points on the connector to the bulb. And therefore we go to 2 and we go to 1. 1 is ground. Over here, we go to 2, we go to 1. 3 is not connected. 2 filaments. Therefore, current flows here. Remember, right turn. We go over here. Instrument cluster. If you remember, in your instrument panel, there's a warning light that you turn on the right signal. That's what this is referring to in the dashboard. In the dashboard, it'll go on indicating, hey, I just indicated I want my right lights, my right signal lights to go on. Over here, same thing. This is the rear. This is for the rear lights. And this is for the front. Right. So everything here has to do with right. How do I know that? Because we put the switch in the right. What about the left? So looking at the schematic, this deals with left. This deals with right. Remember, now we flip the switch in the other position because we want left. So when we have left, we have current flowing from the battery, which is not shown here, right? Green, yellow wire flowing through here, through a blue-red wire. Again, blue-red wire. And we come to a point which has many branches. Therefore, we go, one current flows here. Left turn for the parking. Current flows here. For the rear, left goes over here. For the instrument, again, the dashboard. Telling you there's an indicator you just activated the left turn signal. And another one going over here, wherever it goes to. So the main point is, the starting point is the main component. Like I said, concentrate on main component. A switch is a main component. Understand how the switch works. You flip it either one way or the other way. But the only way it'll make contact is when there is a connection of wiring here and here. There is nothing here. Therefore, how much will I measure all clear? If you remember my other videos that I made, parallel circuits. These are parallel circuits. And what's special about parallel circuits? They all measure the same voltage. So don't we have a parallel circuit here? Look. This is in parallel. This is in parallel. Parallel. Everything is in parallel. Therefore, 12 volts across here, 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 12 volts across here. Therefore, if I want to measure 12 volts, I have to go to pin 2. If I want to measure 12 volts, I go to pin 2. Right? And if I want to measure 12 volts, I go right here. This is to the bulb. This one. To the brown or black wire. As you see over here, it says connector 1, connector 2. And therefore, this goes to ground. If there is no ground, this will be open. This might be 12 volts, or this might be 12 volts. Ground pulls it down to 0 volts. So 12 volts here, 0 volts here. 12 volts here, 0 volts here. Okay, this is the brown. This is the brown wire. Actually, this is the brown. This is the blue. This is blue and black. Blue and black. This is the brown. BR. BR is brown. Blue and red. So therefore, if I want to troubleshoot, I have, as you see over here, what's missing over here? A fuse. No fuse. I don't see a fuse. If I want to troubleshoot, my left turn signal doesn't work. Well, you know what? In a quick way, I go in and look at, does the dashboard come on? If which is over here. If this doesn't work, if the rear and the front don't work, that means that the problem is maybe the switch or something over here. Maybe there is a fuse somewhere along there. Let's say the right turn signal doesn't work. I go to my car in the morning, I turn on the lights, right turn signal on the dashboard doesn't turn. The rear doesn't turn on the right. And the parking lights on the front don't turn. That tells me all these are common. That tells me maybe again the signal, the switch doesn't work, or somewhere the switch doesn't work. If there is a fuse over here, then all of this will not work. So you look at all the symptoms. If one bulb is not lit, obviously, let's say the park, then obviously I'm going to go and say, okay, probably the bulb. But if all rear, park, dashboard doesn't work in an instrument cluster, then I have to say probably maybe the switch doesn't toggle. Okay? Please subscribe to my channel, Automotive Electronic Schematics by Joseph. You'll have more of these, and my other Joe Electronic Schematics. And I was asked about the books that I use. I use several books. There is a manufacturer which I use in school called LabVol, and I use those books. Those are very well-trained books. And I use the manuals from the dealers, as well as using